Good morning, dear students. Welcome back to physics class. Today, I would like to present the topic Elementary Concepts of Differentiation and Integration for Describing Motion, Part B. The subtopics are A. Average speed and B. Instantaneous velocity. As continuation of our last class, when I had talked over the topic uniform and non-uniform motion, for today's class, at first I would like to introduce the subject average speed. You know that an object will continue to be in state of uniform motion unless acted an unbalanced external force on it, which is in accordance with Newton's first law of motion, which you had learned from 9th grade class. But in fact, most of bodies, when they are in motion, may be having not constant speed because of the external unbalanced force act on them. When an object is moving at a variable speed, it is possible to express the magnitude of its rate of motion in terms of average speed. What do you mean by average speed of an object which is in motion? Average speed is defined as the total path length traveled divided by the total time interval during which the motion has taken place. It has the same unit as that of velocity. It does not tell us in what direction an object is moving. It is always positive quantity. It gives magnitude only but not specified direction. So it is a scalar quantity. If the motion of an object is along a straight line and in the same direction, the magnitude of displacement equals to the total path length. You have to note this point. If an object which is in motion specifies its direction as well as its magnitude of distance covered per unit time, we have to define the quantity called average velocity. It is defined as the change in position or displacement delta x divided by the time intervals delta t in which the displacement occurs. So, the average velocity can be mathematically written as v is equal to s2 minus x1 divided by t2 minus t1, which is equal to delta x divided by delta t. The figure shows position time graphs of objects in their motion, which you have studied in 9th class. The first graph shows it is the slope up graph where the object undergoes equal change in position in equal interval of time. Here the change is increment. So the object is moving with positive velocity. Second graph shows it is the slope down graph. Here change is equally but decrement. So it is moving with negative velocity. And third graph shows it is not having slope. Here object undergoes no change in position. It is at the state of rest. The average speed need not always equal to the magnitude of the average velocity. This happens because the motion may involve change in direction so that the path length is greater than the magnitude of displacement. This shows that speed is in general greater than the magnitude of the velocity. Next important part of our chapter is instantaneous velocity. What is the meaning of instantaneous velocity? It is velocity of a moving body at instant of time or velocity at moment of time. To calculate this value, we have to apply a very important mathematical calculus method which is called differentiation. How can define differentiation in general? It is rate of change of anything with respect to something, and its reverse process is called integration. The fundamental theorem of mathematical calculus process shows that both differentiation and integration are the inverse of each other. You have learned about average speed and the calculation of average speed of a moving body. When the same body moves along a straight line, that is, it specifies its direction, then the average speed becomes to be average velocity. You know that the average speed tells us how fast an object has been moving over a given time intervals, but it does not tell us how fast it moves at a different instant of time during that interval. Similarly, average velocity also does not tell us how fast it moves at different instant of time during that interval of time. For this, we have to define instantaneous velocity, or simply velocity v at an instant t. You have to notice this point also. Average speed is equal to average velocity by the situation, which is the same body not only to move along a straight line but also does not reverse its motion. How can define the instantaneous velocity? It can be defined as the rate of change of position with respect to time at that instant. The limit of the average velocity as the time interval becomes infinitesimally short, or as the time interval approaches zero, can be mathematically written as instantaneous velocity v approximately equal to limit delta t tends to 0 delta x by delta t, which is the equation 1, where the symbol limit delta t tends to 0 stands for the mathematical operation of taking limit as delta t tends to 0 of the quantity on its right, which means that the measured quantity, which is minute, which is very, very small, change in position, delta x is very, very small in this time interval delta t. Because the time interval considered to be very, very small, that is, which is approximately come to be 0, delta t tends to be 0. Thus, in the language of calculus, the quantity on the right side of the equation 1 is the differential coefficient of x with respect to t and is denoted by dx by dt, which means that it is the rate of change of position with respect to time at that instant. Then the instantaneous velocity can be written as v approximately equal to dx by dt, which is the equation 2. The instantaneous velocity indicates what is happening at every instant of time. You have to understand that the equation 2 is the differentiation of the position x with respect to t, where t be the time when the same object is at the position x. As I told earlier, rate of change of anything with respect to something is differentiation. Here, the differentiation is rate of change of position with respect to time, which gives instantaneous velocity. This also means that position of an object which is in motion is function of time t. That is, position changes with respect to time t. We can use equation 1, which is limit delta t tends to 0 delta x by delta t for obtaining the value of velocity of a moving body at an instant either graphically or numerically. Suppose that we want to obtain graphically the value of velocity at time t is equal to 4 seconds, which can be represented by the point P in the second graph of the moving body whose motion is represented in the first figure. Both graphs are position time graph. But second graph is the modification of first graph by choosing different scales to facilitate the calculation. For the determination of velocity at any instant of time from position time graph, here velocity at time t is equal to 4 seconds, we have to take the slope of the tangent to the graph at that instant. As shown in figure, a tangent has drawn at the point P in this graph. In mathematics, you learn that slope of a graph is obtained by this equation. Slope is equal to y2 minus y1 divided by s2 minus x1, where y1 and y2 be the y-coordinate values and x1 and s2 be the x-coordinate values, which can be read from the given graph. Let us take the time interval delta t, which is t2 minus t1 is equal to 2 seconds, which is centered at t is equal to 4 seconds as shown in figure 2. Then by the definition of average velocity, which is represented by s2 minus x1 divided by t2 minus t1, the slope of the line p1 p2 gives the value of average velocity over the time intervals 3 seconds to 5 seconds. Here t1 is equal to 3 seconds and t2 is equal to 5 seconds. Now we decrease the value of delta t from 2 seconds to 1 second, then the line p1 p2 becomes q1 q2 and its slope gives the value of the average velocity over the time interval 3.5 second to 4.5 second. In the limit delta t tends to 0, the line p1 p2 becomes tangent to the position time curve at the point P, and the velocity at t is equal to 4 seconds is given by the slope of the tangent at that point. It is difficult to show this process graphically, but if we use the numerical method to obtain the value of this velocity, the meaning of the limiting process becomes clear. This graph is position time graph where x is the function of t, which could be represented by the equation x is equal to 0.08 t cube. The table given above gives the value of delta x by delta t calculated for delta t equal to 2.0 second, 1.0 second, 0.5 second, 0.1 second and 0.01 second, centered at t is equal to 4 seconds. The second and third columns give the value of t1 is equal to t minus delta t divided by 2 and t2 is equal to t plus delta t divided by 2, which is equal to 0.08 t cube, and the fourth and the fifth columns give the corresponding values of x, that is x t1 is equal to 0.08 t1 cube and x t2 is equal to 0.08 t2 cube. The sixth column lists the difference delta x is equal to x t2 minus x t1, and the last column gives the ratio of delta x and delta t, that is the average velocity corresponding to the value of delta t listed in the first column. We see from the table that as we decrease the value of delta t from 2 seconds to 0.010 second, the value of the average velocity approaches the limiting value, that is 3.84 meter per second, which is the value of velocity at t is equal to 4 seconds, which is the instantaneous value represented by dx by dt at t is equal to 4 seconds. This is the numerical method to calculate the instantaneous velocity of the moving body. In this manner, we can calculate the velocity at each instant of time for a moving body. We can show the variation of this velocity with respect to time by means of this graph, which is the figure 3. It is the velocity time graph. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.